Good day everyone, my name is Ray Bahenting Flores and welcome back to my YouTube channel. For today, we will discuss about indefinite integral. And the objectives of this video is that the learners are able to familiarize the properties of indefinite integrals and use it in finding the indefinite integrals of some function. But before we proceed, let us give some statements or a definition that best describe indefinite integral. And it is that indefinite integral is an antiderivative of a function f of x is a function of f of x such f prime is equal to f of x for all x. For us to expand this definition, let us familiar with the properties of indefinite integrals. So the properties are, first we have the integral of dx, which is equal to x plus c. Next is the integral of key dx, which is equal to key the integral of dx, where key is a constant. Next is the integral of x powered by n, or x raised to the power of n, dx is equal to x raised to the power of n plus 1 all over n plus 1 plus c, where n is not equal to 0. Next is the integral of 1 all over x dx is equal to the ln absolute value of x plus c, where x is not equal to 0. Next is we have the property number 5, the integral of e raised to the power of x dx is equal to e raised to the power of x plus c. And for this property number 5, we have another form considering the any non-zero constant key. So we have this integral of e raised to the power of key x dx, which is equal to 1 over key e raised to the power of key x plus c. As what I have said, it is for any non-zero constant key. And for the 6th property, we have the integral of f of x. And again, this property is applicable also for subtraction. So let me read it again. Property number 6 is the integral of bracket f of x plus or minus g of x dx, which is equal to the integral of f of x dx plus or minus g of x dx. Next is, or the last property for this indefinite integral, is that the integral of f quantity of gx g prime of x dx is equal to the integral of fu du. For us to apply the given properties and expand our knowledge about the given statements defining indefinite integral, let us apply this with these given examples. So, example number 1, which is the integral of 2x plus 1 dx. So, we apply, in solving this example number 1, we apply the property number 6 when we substitute the integral sign, and then property number 2 when we exclude the constant, and property number 1 and a property number 3 where we add 1 to our n, which is the exponent of our x. So we came up with 2 the integral of x raised to the power of 1 plus 1 all over 1 plus 1. I am sorry for these mistakes. We have dx here side. We have dx here, so if we read it in the right, so we came up with 2 the integral of x raised to the power of 1 plus 1 all over 1 plus 1 dx plus the integral of dx, or 1 the integral of dx. And proceed, we came up with 2 quantity of x squared all over 2 plus x. And then the final answer for this example number 1 is the x squared plus c plus x plus c. Is it because if we multiply 2 to our x squared, we came up with 2x squared all over 2, where 2 divided by 2 is 1, so we came up with x squared as the remaining. So x squared plus x plus c is the indefinite integrals of this given function here. Example number 2, which is the integral of 6 dx. Yes, the property applicable for this example is the property number 2, and that is we exclude the constant 6 to our given. So we came up with the integral of 6 dx is equal to 6 integral of dx, and by that we are applying also the property number 1. So from our given we have 6, the integral of 6 dx. The indefinite of integrals of the integral 6 dx is 6x plus c. Another example, we have this example number 3, which is the integral of x raised to the power of 4 dx. So yes, the applicable property for this example is the property number 3, where we add 1 in our exponent. So the exponent here is 4, so we came up with x raised to the power of 4 plus 1 all over 4 plus 1. And by that, we came up with x raised to the power of 5 all over 5 plus c as the indefinite integrals of this given example here, number 3. Next is the example number 4. Yes, as you observe, it is very or closely similar to the example number 3, yet we include the constant 3 here. So we came up with the integral of 3x raised to the power of 4 dx. So the applicable property is the property number 2 and the property number 3. The property number 2 is to exclude the constant, and the property number 3 is to add 1 to our exponent, and the exponent here is 4, so we came up with the 3, our constant integral of x raised to the power of 4 plus 1 all over 4 plus 1, so we came up with 3 quantity of x raised to the power of 5 all over 5, and then if we multiply it to our constant 3, we came up with 3x raised to the power of 5 all over 5 plus c. Last example for this for today's video. So we came up with this given example, which is the integral of x negative 1 dx. So in solving this, we are able to reform the given. So in reforming, just remember that the integral of x raised to the power of negative 1 is just the same, similar or the same to the integral of 1 all over x. So from the given integral of x raised to the power of negative 1 dx, we came up with a new given, which is the integral of 1 all over x dx. And by that, it is the property number 4, and it is equal to ln absolute value of x plus c. And that would be all for today's video. I hope you enjoy it, and please do subscribe and click the notification bell for you to be updated. And guys, I have just want to give credit for the information I have used in this video to our instructor, Sir Mateo Caneda, for I have used the LM or the learning material he provided for us. Thank you and God bless.